Hello friends, so this is part one of 5th semester DSE 1 paper solution 2022 of BSc 5th SEM Dibrugarh University. So I'm not gonna complete this whole paper in single video, so just stay connected, okay? So, and hit the bell icon so that you get notified when new video will be uploaded, and you can follow me on Insta. This is my Insta ID, right? So now you see, let's move on to the first question. So here is the first question. An alpha particle with mass m, charge twice e, enters into a magnetic field B with velocity v perpendicular to the direction of the magnetic field. Then the radius of the curved part, the radius, if this is the magnetic field, uniform magnetic field, and a charged particle with charge q enters with velocity v, this is the magnetic field B, then the radius is given by m into v by q into b, right? So here the charge q is twice e, so let's replace q by twice e, then the expression gonna be equal to this. So this is the correct option, right? So hope you have understood this. Now let's move on to the next option, next question, sorry, not next option. So this is Lagrangian equation. This is the next question. In Lagrangian equation, if there are capital N number of particles, and so that the generalized coordinates are, that's given by this is the correct option, and A is equal to thrice n minus k, okay? So this is the number of generalized coordinates, okay? Now Hamiltonian proved that the actual path followed by a physical system between two states in the given time is the one for which this integral is minimized, okay? That is minimized, okay? So now let's go to the next question. So for small amplitude, the oscillation potential energy curve with respect to the distance traveled from equilibrium position, that should be parabolic, okay? That should be parabolic. Now, so let's solve the next question. Here, the time dilation factor, okay, of a moon traveling with a velocity 80% that of the velocity of light. So it is traveling with a velocity with 80% of the velocity of light, right? And the time dilation factor is given by gamma is equal to 1 by root over 1 minus v square by c square. So now if we use this information here, then what we can have, 1 minus v is now 80% of c, means 80 by 100 into c, that's going to be 0.8 c. So let's put here 0.8 c by c, you can write this whole square. So here c gone, so what we have got, so that's going to be equal to root over 1 minus, and square of 0.8 is 0.64, right? And if you subtract it, then you can have under root 0.36, and square root of this is 1 by 0.6, and if you divide this 1 by 0.6, then is approximately equal to 1.66, right? So hope you have understood this. So that's why the correct option is this 1.66, right? So hope you have understood this. Now let's go to the next question, the relativistic formula for kinetic energy. That is the first option, this one, first option, right? If an object approaches the speed of light, then the mass becomes, relativistic mass mr, that is given by m naught, that is the original mass, divided by 1 minus v square by c square. If v approaches to c, so then this is going to be equal to 1, and 1 minus 1 0, so m naught divided by 0, that's going to be infinity, right? So that should be the option, right? So which of the following is the basic principle of fluid mechanics? Momentum principle, energy equation, continuity equation. So all of this, right? So answer should be option 4. Option 4, right? So now let's move on to the next question. What is the next question? So the next question is, so that the radius of curvature of a charged particle moving at right angles to a magnetic field is proportional to its momentum. So there are two questions in question number 2A. So either you have to answer this or you need to answer this. So first let us answer this question. So now let me take a new slide, blank slide. So here I have taken, so suppose here is the magnetic field. So cross represents the magnetic field are perpendicular to the plane and into the plane as well. That means if this is the plane, suppose, and if I write here cross, then the magnetic field line goes into the base and at right angle. Okay, so that means here you can see the cross means this magnetic field lines are entering perpendicularly to the screen of your device that you are using. So this is uniform magnetic field, suppose B, a charged particle Q, suppose, moving with velocity v, as it enters the magnetic field at right angle, then it gonna experience a force, magnetic force, and which gonna make it, take a circular path. So let the radius of the path be r, right? So if you consider this one as positive charge, if you apply the Fleming's left hand rule, then you're gonna get this direction. Okay, so the direction of the force, that force experienced by this charge will be perpendicular to both V and perpendicular to B, right? So hope you have understood this. So now let me explain what I have considered here. So let me write here. So this is twice answer. So let us consider V be the initial velocity of a charged particle, with charge Q enters the magnetic field, B, I have to mention this is uniform magnetic field. Okay, uniform magnetic field B at right angle to the direction of the field, as shown in the figure, and the force experienced by it be, suppose, F, which is called Lorentz force, that is given by, and I'm gonna write it later. Okay, just let me write. This is given by F is equal to Q V cross B. So that means therefore its magnitude is going to be equal to Q V B sine 90 degree, since the V is perpendicular to B, right? So that's why that force is going to be QVB, simply QVB, right? So let me mention one more thing. Here. By Fleming's left hand rule, F is perpendicular to both V and V, right? So that's apostrophe S. Okay, so now let me copy this expression of force. Okay, and let me copy the figure as well. As you can see, as it takes circular path due to this force, that's why this force provides centripetal force, which is equal to mv square by r, where r is the radius of curvature of the path, and m is the mass of the charged particle. Therefore, as this centripetal force is provided by this force, that's why we can write qvb is equal to mv square by r, and if you simplify this, then r gonna be equal to mv square by qvb. So v cancels v square to give v, so that's why it turns out to be r is equal to mv by q into b. Here you see qvm, you can just write this one like this: qv, this part is constant, so mv represents momentum, so we can say if this part is constant, so r is proportional to mv, so that means the radius of curvature is directly proportional to momentum, right? So hope you have understood this. This is the question number 2. Now let me go to the remaining part of this question. So there was another question, same question number, or you have to solve this one. So take the screenshot of this page first, second, right? So let me take that question. So in this question here you can see, so let's solve this question. The gyro radius and the cyclotron frequency of proton. Okay, so first one, so mass of proton m, that is given by 1.6726 into 10 to the power minus 27 kg. Charge of proton is equal to the charge of electron, but it is positive in nature, that is 10 to the power 1.6 into 10 to the power minus 19 coulomb. And here you see velocity is given 10 centimeter per second. Velocity is 10 centimeter per second. If you convert it into meter per second, 10 into 10 to the power minus 2, so meter per second, that's going to be equal to 10 to the power minus 1 meter per second, right? And magnetic field is given, B is equal to 10 to the power 4 Gauss. So that is nothing but 10 to the power 4 Gauss is 1 Tesla. Right? So gyro radius, that r is equal to, that is given by mv QB. So if you put the values here, 1.6726 into 10 to the power minus 27 into 10 to the power minus 1 divided by Q is here 1.6 into 10 to the power minus 19 into B is 1 Tesla, right? So I have used this values here in this formula, so I have got this. If you calculate this, then you will have approximately 1.045 into 10 to the power minus 9 meter. That's what you will have. Okay, so now we need to find the cyclotron frequency. Okay, so just let me divide the page. Cyclotron frequency. So that is given by nu is equal to BQ by 2 pi m. That's given by BQ by 2 pi m, right? So let's put those values we given here. So if you put those values, then what you're gonna have 1 into 10 to the power 1.6 into 10 to the power minus 19 divided by 2 into 10 to the power 3.14 into 1.6726 into 10 to the power minus 27, right? That's what we're gonna have. So if you calculate this, it's gonna be approximately 0.1523 into 10 to the power 18 hertz. So that is, if you write the decimal here, that's gonna be 1.5 into 1.523 into 10 to the power 17 hertz, right? That's what we're gonna have. So now then we need to find the same thing, gyro radius and cyclotron frequency for an electron. Okay, for an electron. So take the screenshot and let me clean this. Okay, so here we need to change the mass of the electron. So now we are going to solve 2. So 2 mass of electron instead of proton. Now we're going to write electron. Mass of electron is given by approximately 9.1 into 10 to the power minus 31 kg, and that is the only thing we need to change here. So here let me use the mass of electron here. Just let me. So result gonna be changed. So mass of electron 9.1 into 10 to the power minus 31, right? And the answer is going to be 5.6875 into 10 to the power minus 12. That's what we're going to have. And here again change the mass of replace the mass of electron mass of proton by mass of electron, right? Then what you're going to have, cut this and cut this as well. So mass of the proton 9.1 into 10 to the power minus 31, right? So and it's going to be equal to 0.028 into 10 to the power 12 hertz, and if you bring the decimal here, then 2.8 into 10 to the power 10 hertz. Okay, so this is the cyclotron frequency of electron. So hope you have understood this. So now let's go to the next question. So this is the answer to question number 2b, and here is the definition of generalized coordinate. And if you want to understand better, then you can watch the video. Link is given in the playlist. I have written generalized coordinate and I have provided the link of that video. Okay, so check the description box. Okay, so here you see the position vector of a particle, ith particle, suppose Ri, which is a function of generalized coordinates, q1, q2, dot dot dot, q3n, and t, right? So this is the position of a particle, ith particle, right? Then here you see it represents the position. Okay, these are the generalized coordinates. Then the generalized velocity that will be given by Ri dot, that Ri dot, that gonna be equal to sigma f, where f is the number of generalized coordinates, j is equal to 1, so that will be given by del Ri by del Qj, sorry, that's supposed to be Q dot j plus del R by del T, right? So here f is the number of generalized coordinate. If there are n number of particles and k constraints, then this is the number of generalized coordinates, right? So this is the expression for generalized velocity, right? So now you see here generalized velocity associated with associated with particular coordinate, generalized coordinate. Qj is this. Okay. This is the velocity expression for generalized velocity. Right. So now expression for generalized force. Let me go to the new slide. Okay. So we consider the expression for generalized force is given by this expression. This is the required expression for generalized force associated with generalized coordinates Qj, right? So hope you have understood this. Now let's move on to next questions. Now you see for those questions 2C, 3A, 3B, right, and 3B or, okay, and 3C as well, I think. Okay, I have to check, I don't know, I'm not sure about this, but for 2C, 3A, 3B and 3B or, I have already made videos on these topics, so I have provided the link of the answers to these questions like this way. Let me show you. I have written question number 2C and I have provided the link of the video where the answer is given. Okay, similarly 3A, 3B, okay, links are given here, and if you check the description box, you're gonna get there, and 3B or as well. Okay, so I have given the answers to those questions. So if you check the description box, you're gonna get the link of those videos where you're gonna get these answers, right? So thank you for watching. See you in the next video. Stay connected and give me 100 likes for the next video.